our speaker tonight is Rear Admiral Tim Gallaudet, who is the Assistant Secretary of Commerce for Oceans and Atmosphere. He is also the Deputy Administrator of National Oceanic and Atmospheric Administration, otherwise known as NOAA. Before that, from 2017 to 19, he served as the Acting Undersecretary of Commerce for Oceans and Atmosphere and NOAA Administrator. Before that assignment, he spent 32 years in the U.S. Navy, completing his service in 2017 as the oceanographer of the Navy. In his current position, he leads NOAA's Blue Economy activities that advance marine transportation, sustainable seafood, ocean exploration and mapping, marine tourism and recreation, and coastal resiliency. He also directs NOAA's support to the administration's Indo-Pacific strategy. He oversees NOAA's Arctic research, operations, and engagement, and is leading the execution of NOAA's science and technology strategies for artificial intelligence, unmanned systems, Omics, cloud, and citizen science, which I think you're going to hear a lot about tonight. He has a bachelor's degree from the U.S. Naval Academy and both a master's and a doctorate degree in oceanography from Scripps. So that really set him up well, I think, to talk tonight to us about NOAA science and technology, accelerating innovation in the 21st century. Thank you so much, Tim, for joining us. And I'm going to hand you the floor, so to speak.
Hey, Jennifer, thank you. Just a quick sound check. Do you hear me okay?
Yes, sounds good.
Awesome. Well, that was a really wonderful introduction. Thank you so much. And, you know, I wish I was as cool as you, though, because I don't have an island in the Gulf of Maine named after me. So that's a pretty neat thing about you and your background.
Well, you just come visit. We'll show it to you.
Oh, I would love to. In fact, yes. It is unfortunate I can't be there in person because I love that area of the country, and I have friends who live there in your region, and I would really have liked to have done this. But we'll do that next time, hopefully soon. I'm going to talk a bit about some science and technology initiatives at the National Oceanic and Atmospheric Administration, or NOAA. Now, your colleagues and the students you support know much probably about our mission. We have a range of activities that go from weather forecasting to satellite image analysis to ecosystem restoration and ecology to fisheries management and bathymetric and shoreline mapping and all sorts of wonderful environmental science activities, as well as this policy-related work. But I thought I'd focus it a bit on some of the really cutting-edge, emerging S&T efforts we're doing as we look to the future. And now we're living in this sort of COVID era. We're finding that S&T is really going to answer our needs to be able to move forward with coastal and ocean science and in the 21st century in view of some of the restrictions that we're dealing with. So I'll talk a bit about that. And so we'll just get underway. Next slide, please. So one of our really exciting developments of last year is I'm the deputy administrator currently, and I chair our Science and Research Council. And I looked at what was going on in the world in terms of S&T, and I realized there is some transformational activity happening in our agency and around the country that really we need to accelerate and advance. And so I selected 6 areas that I thought, kind of encompassed the opportunity that exists to really improve our performance, our efficiency, and really change our culture. And these are the ones listed. You hear artificial intelligence. I'll focus on that tonight with respect to our role in bathymetric and ocean mapping and exploration, but also autonomous or unmanned systems, an area called Omics, which is basically microbiological big data. It encompasses metabolomics, genomics, metagenomics, epigenomics, all these really fascinating areas that are transforming the way we understand biological systems and ecosystems. And so it's a very exciting area there, primarily leveraging next generation gene sequencing. And then there's this whole area of data and big data. So we've developed a data strategy. And we also include one on cloud computing, cloud services, for a range of activities that basically, with the explosion of data that's coming into, various labs like yours, agencies like mine, we really have to increasingly leverage the commercial cloud to help us deal with this data. And so we have a strategy to approach that. Not included in this list, but our final strategy was on citizen science or crowdsourcing, or prize competitions. All of those are activities because of the quality of personal devices and technology are allowing us to help leverage the public to gain access to important data to advance our understanding of the environment and apply it. So it's very exciting. Now, the subtext here in this slide, these S&T areas are advancing our main priorities. And just so people are aware, this is important. My agency, NOAA, which really it touches really every American life every day in a positive way, we've articulated 3 top-level priorities. We have one called weather and water, and it's basically severe weather prediction and modeling and water prediction and modeling, because like hurricane season right now, that is what affects lives and property. And so our ability to get back to world number one, world leadership in our weather model is an important focus of effort. You hear on the news about, the European model beating the American model in prediction. Well, those days are over. We have worked very hard and have a very deliberate approach now and strategy to advance our weather modeling and be the best in the world, because we have the world's greatest weather experts, meteorologists, computer scientists, and we have just need to organize better and be more efficient in how we're doing this. So there's a long story there, but we're improving our ability to predict severe weather like tornadoes and hurricanes and winter weather and fire weather. The second priority we call our blue economy priority, because it's an important area now of our nation and really around the world about harnessing the potential of our coasts, oceans, and Great Lakes to support our prosperity nationally, but in a sustainable way. So that includes fisheries, marine transportation and navigation, marine tourism, also exploration and mapping, which I'll talk about today, and coastal resilience to weather and natural disasters and other challenges like sea level rise. Very important for coastal economies. And that matters because 40% of the U.S. population lives in coastal counties. If you were to take all the GDP or income, if you will, of coastal counties, that would be of the U.S. That would be the 3rd largest GDP in the world. So think about that. So our blue economy priority, taking NOAA's data and services to support local and coastal economies, is a really important area. And the last priority we articulate that leverages these S&T areas is space innovation. And that's an important one because, first off, our weather satellite programs, they're multi-billion-dollar programs. And in the past, we assumed all the risk of these programs, and if they didn't go well, we took a major hit and we didn't succeed, and it cost a lot of money. Well, our space innovation effort is about taking our weather satellite efforts and leveraging the private sector. There's a burgeoning space industry. I think SpaceX is most representative of this, and we want to leverage that better to advance our weather satellite capabilities. We have 18 weather satellites right now, and we're moving to work more with the private sector who can innovate a lot quicker than we can. Okay, that's my big scene setter. Next slide, please. So these technology strategies that we've advanced, we're working on developing corresponding action plans with 5-year plans to identify the things we will do and which offices will do them and when they'll finish them to move forward these areas. And it's very exciting. I list here some of the common themes. And this is important, I think, for the audience, because as we as ocean science and marine science professionals move forward, so these are some of the big topics we have to address. And I won't go into every one of these, but the one I think I'm most interested, the two I'm most interested in are workforce and partnerships on the bottom. I think advancing partnerships with academic and science institutions like Shoals and University of New Hampshire and Cornell, as well as the private sector, and also providing for an ocean literate workforce. These are areas we really need to move forward in to advance our understanding and the sustainable use of our oceans and coasts, as well as the health of our oceans and coasts. And so these are some of the ideas, the big picture areas that our strategies focus on. Now, next slide, please. Today, I'm going to focus a bit on artificial intelligence and machine learning. I list the goals here of our recent artificial intelligence strategy, and we're currently developing this action plan, which, strategies for those who are kind of uninitiated in this type of high-level management and leadership area. Strategies identify where we're going to go and why. And the answer is, for this is where we're going to go. We're going to advance the workforce. We're going to advance partnerships. We're going to accelerate the transition from research. And we're going to reorganize to make sure we're more efficient. That's where we're going to go. And then the why is in here. The why for artificial intelligence is this. We have the opportunity to apply artificial intelligence in ocean science and atmospheric science to basically improve our performance, to improve our efficiency, as well as transform our culture. Because, heretofore, our culture, I think, has been rooted in different efforts, like with modeling, using the geophysical equations of motion, for example, which are important and we were not going to dismiss. But there are data-driven predictive models that are showing improved skill compared to other types. And I'm talking about weather and ocean models, et cetera. And so I'll talk about some of this right now. So here's our strategy. Here are the goals. That's what a strategy does. A plan talks about the actions you will do, when and how. And we're working on that right now. So let's talk a little bit more about artificial intelligence. And by the way, the definitions vary. There are many, and I actually, interestingly, I received a master's degree at Scripps. I worked on that in 1989, and then came back later and got my Ph.D. in 2001. And my master's degree work was heavily involved with AI and machine learning. And so this is not like necessarily new. What's new is our computational power and our data. We have data sets and a computational power now available to really harness AI in a way that never before could be done. And that's why AI is becoming such a kind of just a transformational capability across the country and the world. So moving forward, go ahead. Next slide, please. Here's some, if you could go back, please. You missed one, Adrian, thank you. There you go. No. Well, actually, we'll stop here. Okay, yeah. So, here is a great example of what we're doing. The image you see on the right is a satellite image showing, the smoke from a wildfire. And one of our big efforts right now is to support disaster response efforts, from wildfires to flooding, and even significant snow events in the West and in the Great Lakes area. Because when emergency managers have to respond at emergency operations centers, it becomes a very data-driven effort, and it's not just weather data. It's for example demographics. Where are there population centers that have more vulnerable people? And of course, if you look at elevation, where are they more susceptible to flooding? And for wildfires, where is there areas of dry and arid land and whatnot that will be more prone to the rapid spread of wildfires? So our data is really important. And so we have teamed up with the Department of Defense. They have a joint artificial intelligence center. Also the Department of Energy. They run big national labs. And we are working to move forward to apply AI, rapid automated route planning, as well as pre-planning for staging of relief supplies to accelerate the efforts of first responders. So it's a very exciting time. Today I participated in a press release on this effort. It's called the First Five Consortium. And First Five refers to the first 5 minutes of any natural disaster where so much, where really the lives and property are so dependent upon immediate action. You'll see the press release soon, or look it up. And so that's one example, an important example of applying AI and to environmental science to really do great good for our citizens. Okay, so next slide. Another example for what we do, and I'm just kind of sharing you the sort of the specifics of just a few ideas of or instances of how AI applies to environmental science and applications. You see, I list everything on the left-hand side, but the two examples I'll highlight of many that we're using today are in the middle. This community radiative transfer model. This is a radiative model that a radiation model that we use to calibrate our JPSS polar satellite system. And it's important because that satellite is always feeding our weather models, and we use in our predictions for hurricanes and all the severe weather I talked about. And so we previously had to run this model every day to help calibrate our satellite system, and it would take about an hour and a half. Global model, tons of data inputs. And when we applied artificial intelligence techniques, we were able to reduce that compute time to a second. Orders of magnitude improvement in compute time. So that's when I talk about transformational improvements in efficiency. That's what I'm talking about. The compute improvements are just remarkable, and that's why we're going really fast forward in applying AI to modeling. Now, another example is on the left, or pardon me, right, excuse me. And this is using machine learning for rip current detection. This is really important because around the country right now, we really don't have this capability to do sort of what immediate warnings on rip current occurrences. And so we are now partnering with people like Surfline and others, and counties and cities to apply machine learning to their surf cam videos, and then using those to issue immediate rip current warnings. Now, I don't know how many people are here are coastal residents. I assume a good number, but I read in the news all the time about rip current drownings. Today, I read about one, a young individual in his 20s drowning in Lake Michigan. There have been literally half a dozen drownings in Lake Michigan due to rip currents and heavy surf just this month. Those are avoidable deaths if we know about the hazardous conditions like these. And of course, they happen in North Carolina and California. So, I think this is just a great application of using machine learning and applying predictive capabilities to save lives and property. Just two of many examples. Okay, next slide, please. Now, another one is about precipitation prediction. And this is important because heavy precipitation events, affect cities and people. They lead to frequent occurrences of drownings when people stay in their vehicles and try to cross roads that are flooded, as well as crop damage and the like. And there's a lot here on this slide. I'm not going to go into the details, but if you can read the text, basically the bottom line is this. When we applied AI techniques to this predictive probabilistic ensemble model, we were better able to predict areas where heavy precipitation occurred, and equally important, where it wouldn't occur. And our previous predictive model wasn't good at predicting where flooding would not occur or heavy precipitation. So this is just an example of another application. A lot on this slide. I won't go into details, but I think you get the gist. Go ahead, next slide, please. Now, let's talk about maybe the main topic of my conversation, and that's ocean mapping. Now, I'm so pleased to be giving this lecture, Jennifer, or seminar, because I understand, I think your boss is Dr. Larry Mayer, who is probably the world's authority on ocean mapping. Am I correct there?
It's Diane, but it was Larry.
Okay, well, so Larry's moved on, but that you
Yeah.
know who I'm talking
He's still
about.
with UNH, still doing great work.
Absolutely. Well, Larry's a great partner and a friend, and in fact, he was a teammate with my thesis advisor, Dr. Christian Demoustier, and University of New Hampshire is really a world leader in ocean mapping expertise. And so this is sort of what I'm going to really focus on a bit, and it's important because we were able, based on what NOAA does and our partnership with UNH, we got the White House interested. And so the president signed a presidential memorandum to advance ocean mapping and exploration of the U.S. exclusive economic zone. That's a big deal because what that is that makes ocean mapping a national priority. That's huge. That means we get more money and budget for it and support in a number of different areas from the interagency. That means every department that does this stuff, like BOEM and Department of Interior, even NASA, that's doing great exploration and mapping work, are supporting it so they can better do the same thing on other planets. And so this is huge. We're really excited about that. I mean, the program we have to explore our oceans and map them is really significant because we've not even mapped half of our underwater territory. Our underwater territory, our EEZ, is larger than our terrestrial territory, and we haven't even mapped half of it. I mean, in fact, we haven't even mapped the world's oceans to the same fidelity we've mapped NASA, the moon, and Mars. Think about that. And when you include the ocean volume for ocean exploration, we've not even explored 5% of it. And that's why NOAA has discovered new species, new geologic features, new oceanographic features, and even new seamounts, which we've named recently. Every year, we do this every year, and it's exciting. So NASA has about a $5 billion program to go to Mars and beyond, and I think our program is just as important because we're not exploring deep space like them. We are exploring our own planet's inner space. So let's talk a little bit more about how we apply AI to this wonderful area. Next slide, please. Okay, so one of them is we're applying robotics to mapping. Now, this is hydrographic surveying. And what we've recently done is we have automated some of our survey boats. I have experience here in the Navy. I worked on a survey ship with 4 survey boats. I mapped the Arabian Gulf and other areas, and it was really important because I came back later on an aircraft carrier and navigated off the maps I made or charts. So a great area here. We do it at NOAA to map our coastal areas for safe navigation, and really important too. Yeah, go ahead. Oh, I'm sorry, I thought there was a comment. Okay. And so, we map our coastal areas, certainly after hurricanes, when ports might be closed because they're uncertain about navigation hazards. We have a response team called navigational response teams that rapidly map and chart our harbors. And our U.S. seaports are really important. I mean, they see an economic throughput of about $5.4 trillion a year. That is a quarter of U.S. GDP. So this is an important area, and we are beginning to automate these boats where we can have them be driven by people or not. And it's an exciting advancement. We've started to do surveys with our boats on our ships that can be operated by human crews or not, and that's just allowing us to be much more efficient. And I'm really excited about our progress here. Now, next slide, please. Here's an example of some of the data we've collected. We've done this in a number of areas. We've done this in Alaska, and we've also done this in the Gulf Coast. In fact, we're partnering with a private sector partner, which we're trying to do more of, and that is Fugro. And Fugro has an autonomous boat, for example, that's mapping an area in Florida right now, a coastal area that's really important for navigation. It sees a lot of vessel traffic. And so that's just the idea of applying this and getting real data that's of use to mariners with great economic impacts. Now, and to go back to when we talk about AI, I didn't really elaborate, and forgive me, but so AI includes a number of different areas like these algorithms that include neural networks and deep learning and machine learning, but also autonomy and autonomous system and robotics. And that we use the the definition that is applied in the 2019 executive order from the White House on maintaining American leadership in artificial intelligence. And that broadly included autonomous systems and robotics. So that's why you'll see a heavy emphasis here. Next slide, please. Next slide, please. Oh, and here's an example of those navigation response teams that I talked about. And here, this, I believe, is a survey we were conducting to kind of work out the kinks and demonstrate this off the NOAA ship Rainier. And I've been on board one of our other ships, the Thomas Jefferson, and I actually got to pilot one of these autonomous surface vessels. This is what autonomous survey. Okay, next slide, please. Now, here is sort of one of the raison d'etre of unmanned systems, autonomous systems, and the like. This is a team of our surveyors that were in Alaska, and you see one of our survey boats near a glacier. One of the main purposes of applying autonomous systems, and I say autonomous here because when the term unmanned, UXS, unmanned systems, is we use that, but in reality there's no unmanned system that's unmanned. It takes a lot of people, and that's why the picture on the right applies. A lot of effort and R&D and expertise to operate these things. But at any rate, I use the picture of the glacier on the left because these systems are perfect for what they call dull, dirty, and dangerous activities. And so we can use autonomous systems to get really close into shorelines where you don't want people because it's not safe. And that's the beauty of these things. They just improve the efficiency and the safety of our operations. Next slide. All right, a couple other examples of applying machine learning to ocean mapping. Now, on the upper left there, I show a picture of a bathymetric surface, and we've applied machine learning to basically do data QC and remove dropouts and erroneous signals, and really improve the signal to the noise processing filtering that prior to this was probably done not as effectively. And machine learning we're finding is seeing much more higher quality control. On the upper right, I depict picture. These are all related to elevation data, and we're also using machine learning to not only improve the quality but also compress the data more effectively and efficiently. And that's really exciting. We found that we can compress that data by a 20-fold factor and retain 99% accuracy. Those are some good metrics. Lastly, on the side scan sonar image you see on the bottom, same. We are using that to better detect hazards to navigation, and that's just incredibly important for our maritime safety for vessels, traffic, and maritime commerce. Okay, next slide, please. And I should mention too, Jennifer, we work with UNH closely on all these activities, and they've been wonderful pioneers in that activity to apply robotics and machine learning to ocean mapping. So really glad that I could be here with you and give a shout out to Larry and his team. Okay, now mapping is about basically creating charts, looking at the bathymetric surface of the seafloor. Exploration is about a little more. It's about making a map and then getting down vessels, ROVs, AUVs, to look at what's happening there and really understand what's going on in the ocean and the water column. And so we have a number of really excellent efforts ongoing in this area. And the analogy is like NASA, right? NASA's going to Mars, going to the moon, going to Mars. They want to explore the space. That's great. A lot of important things there. Understanding or satisfying human curiosity, learning new science, getting technology spin-offs. And I wager we have the very same need in our inner space of the deep sea. with even a more important advantage because it's our planet. And we need to understand it for so many challenges like understanding climate and understanding all the potential sustainable uses of our ocean, like energy, like critical minerals, safe navigation, fisheries and habitat mapping for fisheries, and the like. So we have a ocean exploration Cooperative Institute, which is a really interesting concept or entity. These are multi-university and institution teams that we fund. We fund this particular one, $95 million for a 5-year period to support us in the exploration field of the ocean. This includes University of New Hampshire, Woods Hole, MIT, University of Southern Maryland, or pardon me, Southern Mississippi. I'm living in Maryland, forgive me for that. And that's just a wonderful collaborative effort, as well as Robert Ballard, the Discovery of the Titanic's Ocean Exploration Trust. So that's a great effort. And so we do this in a huge partnership with those entities. We also have industry partners, which are increasingly important. We have signed agreements with 6 different industry partners that are allowing our scientists to go on their ships and collect data for this effort of exploring the ocean. That includes the Schmidt Ocean Institute, an outfit called Vulcan, which is Microsoft's founder Paul Allen's institute. It also includes an entity called Oceanic, run by Ray Dalio and his Ocean Discoverer ship, and HOVs, and several others. So we're very excited about those. And so why don't I move on to the next slide, and I'll talk about some more examples. One of them includes, which you see here, a wide range of ROV activities. So even though ROVs aren't strictly autonomous, there are a lot of autonomous technologies and algorithms that go into operating these things. So you have an ROV pilot, and I have operated an ROV before on Bob Ballard's ship, the exploration vessel Nautilus. And so there's that, but it's really difficult to maintain entirely. And so there's autonomous algorithms that go into the autopilot mode of these robots. And so increasingly important to that. And then I show some examples here. One is from our ship and up on the upper left. And then Bob Ballard, and you see our exploration vehicle, the Deep Discoverer, on the upper right. And that's the beauty of this, is that it's helping us map and explore our oceans, which we still know so little about. Okay, next slide, please. This is a wonderful example. So 1960, we sent down a human-operated vessel, HOV, if you will, vehicle, to the Marianas Trench. And we set the deep diving record. And just recently, a private equity investor named Victor Vescovo of Gallaudet Oceanic, who we now have a partnership with and who's mapping the Pacific for us, he broke that record with his own HOV. Now, diving with a human down to full ocean depth of about 7 miles in the Challenger Deep and others is a little dangerous. And this is a depiction of the Orpheus AUV that Woods Hole has developed in partnership with us to go to full ocean depth, and it's a lot cheaper and it's a lot safer. And then think about this. I mean, it's exciting to think about sending a human down into a submersible and the deepest part of the ocean, which we supported. But if we could send dozens of these for the same price and really understand and explore all that area, how much better is that? So that's what we're doing in Woods Hole. It's a very exciting development, the Orpheus AUV. Okay, next slide. And here is an interesting example that I find. It's data. So we're working with University of Southern Mississippi to provide a data assembly center to take ocean exploration data, and there's a ton of it. It's bathymetric multi-beam data. It's video from our ROVs, and it's other samples collected and data about those, and archiving it in a center where the data is more discoverable. And the key about AI is this: to automate the discovery and application of this data, it takes making the data what we call AI ready. That's an important element. data sets vary and they're different. And so creating standards for how the data are formatted with metadata, et cetera, it's necessary. It's necessary to be able to rapidly apply AI to data sets. Disparate data sets that are all over the map take time. They take nurturing. I have 3 daughters, and they're all school age, and they take time. So it's the same thing. You have to apply a lot of nurturing to data to get it ready to use AI algorithms for. And so we're investing heavily in these centers to make our data AI ready to understand the ocean and all its information and content better. Okay, next, please. And related to that is doing the same thing with our video content. We have hours and hours of video content. And so we're working also to use AI to more rapidly access it and understand, if we could throw in a keyword to capture all the elements of the video data set we have, or trove of it, so we can better understand what's happening and explore it and pursue scientific objectives. I'm going to use an analogy here that might make this more concrete. Another AI example at NOAA that I thought was just brilliant was we had a NOAA scientist in Hawaii. Her name is Dr. Ann Allen, and she's a marine mammal scientist, and her job was to basically take a bunch of acoustic data on humpback whale vocalizations and determine and assess, where they were most likely to be during different times of the year, and their abundance, and so that way we could better manage and impose rules, for example, on vessel traffic that would not harm these endangered species. Well, she had 170,000 hours of acoustic recordings, and previously analysts went through that manually, listening to them and just kind of doing using very rudimentary tools to try to identify distribution and abundance. And it was tough, it was tough. Well, Ann got with Google, Dr. Allen, and Google said, we can do this. We're data people and we have some AI expertise, and that's what they did. They developed AI algorithms and data-based management that allowed her to determine species distribution and abundance rapidly. With all that data set in a matter of just less than days instead of years. And that's what AI provides. And we're doing the same thing with ROV video of our deep oceans. Next slide. Lastly, I use these images to talk about a great effort, and that is leveraging the commercial cloud. Here you see on the left an acoustic profile of a seamount, and that little yellow streamer is a methane seep release. And that's really important data for people like the Bureau of Ocean Energy Management to know where methane releases are that we can potentially tap into. And then you see on the right a depiction of a seamount. And seamounts are also important navigationally because they affect submarine traffic, as well as can be potential sources, for example, of very interesting science regarding hydrothermal vents and the like. And so, what we're doing is it's a lot of data, takes a lot of processing power, and we're pretty rapidly eclipsing, what we can do with our own supercomputers in the government and at NOAA. Well, the commercial cloud, is the answer. If you look at providers like Microsoft and Amazon Web Services and Google, they have a ton of compute. We to purchase the hard iron computers will cost us a lot of money, but we can lease that service, and this is good business for these people. They want that, and these are American companies. And how great is that we can obtain that service from American companies and help that foster, our economic recovery in this COVID era, which is really needed. So that's what we're doing, and we're doing that in this area to satisfy our needs to map, explore, and characterize our oceans. Okay, last slide. So that's it. That's my talk. I'm probably giving you a little extra time for questions, and but I just want you to know that we've applied science and technology at NOAA in the areas I've talked about to rapidly advance and improve our performance for our really important mission. We with our weather service, for example, and ocean service, protect lives and property every day through our other activities like fisheries and with our satellite data. We contribute to our national economy. And, when you kind of wrap it all up, our S&T efforts in applying it to the services we provide affects every American life every day in a positive way. And it's important that we move forward in advance, and these S&T areas that I've talked about are helping us do so. So thank you for being so attentive, and I'm happy to take a few questions for as long as we got.
Excellent. Tim, you'll want to turn down your volume so that we don't have a feedback.
Okay, I'll try.
Okay, see how this works. Okay, all right, that sounds good. So if anyone has any questions, please put them in the chat. Please type them in, and I'd be happy to read them. I'm going to kick off with a very self-serving question, if you don't mind. I took it upon myself to listen to this and listen for things that I think I hear you saying are important skills for us to teach undergrads. So that's my question for you. Like, what you just gave a lot of breadth, and I'm like, wow, feeling a little overwhelmed. There's a lot that I want to teach undergrads based on that talk, which was great. Thank you. What would you distill maybe to like your top 3 skills or topics that you think undergrads, you were talking about workforce development, and all of us educators would like to help serve that. So how would you answer that?
Hey, Jennifer, first let me commend you for this, because our educators do not get the credit or compensation they deserve. So for you to tap in and say, how can I, be better and serve my students better, is like such a nice thing to see. And, I've been pretty fortunate in life, and you read a nice little resume of me, and I owe everything to educators. And so, well done to you. I would say, well, first of all, one of the things is the main topic is, advanced S&T is it's really important for educators to stay current. And I've seen a number of our educators really do that in a fantastic way. Like, for example, we have these wonderful entities called National Marine Sanctuaries. There's only 14. They're all around the country, and they are like national parks. They're underwater national parks. And they do great education and outreach, and they're very innovative. And all of them, in different degrees, have sponsored robotics efforts and competitions, like Gray's Reef in Georgia, Thunder Bay in Michigan. And so I'd say the important thing is, stay current. It's important to track these things. I talked about Omics and environmental DNA and next generation gene sequencing. Expose your students to the latest and greatest, because they're going to be the professionals and the experts to apply and advance those in the future. The other advice I'll have is this. I heard a great term the other day, and the term is modern polymath. And what that is, it's about those people that you see out there who are not just like super experts in one field, they're super experts in many fields. And it's kind of like the term that was used in the past of Renaissance man or gentleman scholar, or you've heard them. But really, the modern polymath is that term of art where I think more and more in the future, to remain competitive and succeed as a nation, our STEM professionals need to be not just good in ecology or meteorology or oceanography, they need to be good in all of them. And they also need to be good in other things like computer science and electrical engineering and data science, and you name it. And it's a tall order, but with the explosion of information systems and et cetera, it's achievable. And those are the types of people, or that's kind of the skill set that I think we need to nurture going forward.
Excellent, thank you for that answer. So Jackie Webb, who works at URI, she wants to elaborate a bit on the undergraduate question. She wants to ask, can you talk about how undergraduates can get involved in NOAA activities, especially the new Cooperative Institute?
Hey, Jackie, thanks for your question. I'd love to meet you because this new Cooperative Institute is awesome and it's going to do great things. And of course, you would need to contact your URI faculty and staff could point you in the direction of Cooperative Institute activities there at your institution. But there's also, I would get aware and be mindful of the fact that NOAA has a wide range of undergraduate and graduate scholar and intern opportunities. And in fact, you could kind of engage our education office and look online at what those are. In fact, my oldest daughter applied to one of those. And the other area that you could look into is an area called Sea Grant. And Sea Grant offers scholarships and opportunities for education in the same area all around the country. So I don't know if it's Rhode Island Sea Grant or New England Sea Grant, but there are Sea Grant programs all around the coast and Great Lakes. And if you could look that up and find what kind of opportunities they also have. So our internships and scholarships are one, and our Sea Grant activities are another. But you should have folks at URI that can point you in the right direction because they are a member of this. I didn't name them, but they're a member of this Cooperative Institute, and they're an important partner that we fund significantly for that purpose.
Yeah, we do a lot of work actually with New Hampshire Sea Grant, so a lot of great opportunities there for students. So Diane Foster, who is the relatively new director of the Marine School at UNH, she has a question. So she thanks you for this interesting presentation, and she says, can you offer your insight on future university partnerships NOAA will be looking for?
Was that Diane, Jackie, or Jennifer?
Diane Foster.
Okay, Diane, I look forward to meeting you. I'm sorry I've not been current and didn't know that you succeeded Larry, but that's a great question. Well, first off, we're going to maintain what we got. Our cooperative institutes, for example, are very important partners, as well as these entities we have cooperative science centers. But as kind of we go forward, I think one of the things we're really keen on is expanding those and increasing our engagement through the various venues we do this through. One of them are, for example, zoos and aquaria. And so if there's any relationships that you might have with those, we can leverage and coordinate with you in that. Another is, and I think this is really important that we're moving forward with, and I touched on, are public-private partnerships. So I mentioned FUGRO, for example, and autonomous systems. Well, if you or any other university entity is also partnering with has a public-private partnership with people like that, then we all should be talking. We should be working together. And I don't have the full range, for example, on who else FUGRO might be working with in the U.S. in terms of the academic community. But if they are, we need to be connected. And so there's examples like that. So, our current, we have, really, and the topic of partnerships is a big one. So I would say that, long story short, our CIs, cooperative institutes, those that exist now or have a priority. Then those other partnerships like Aquaria, like the National Association of Marine Laboratories, which we work with closely, as well as any public-private partnerships that can bring us together. But we are about partnerships. And if you saw my AI strategy goals, partnerships was one. That is an effort in every one of our S&T strategies and everything we do right now going forward. So many opportunities. Happy to follow up and send me a message after this, and I'd love to connect with you.
Very closely related is a question from Robin Tyner. And I think you know Robin Tyner based on these conversations. And the specific question is there RFPs on the horizon for private companies? You kind of alluded to, you know, this topic.
Well, first, let me say, hey, Robin, she's a shipmate of mine, a Navy captain, and we work together, and she's wonderful. So, hey, good to hear from you. I can't believe you're joining me on this. I'm glad you're interested. And the answer is yes. In fact, just yesterday, we released a news clip on a $3.1 million grant to like 20 small businesses on a wide range of technologies that include aquaculture, machine learning, and AI for our various mission areas. So there was a ton of them. I could connect you with the folks running these contracts and grants and efforts at NOAA to advance our public-private partnerships. And so there's a whole wide range of them, and I'd love to work with you on those, Robin.
I feel like we're uniting people here. This is great. Here's a question from Jay McKay. Jay says, thanks, Admiral. Great talk. As a fellow Marylander, is there any chance you could help bring some of your autonomous tools to Chesapeake Bay to help us advance HAB monitoring? Back to you.
Hey, Jay, absolutely. In fact, you'll love this. First off, we demonstrated through the pilot project, interestingly, with Monterey Bay Aquarium in the Great Lakes of an autonomous underwater vehicle that used a very interesting technology to sample for HABs. And we've proven the technology, we're working to expand it. In the Bay, we have not done that. We intend to, but we have been demonstrating autonomous technology. The two times that I've driven an unmanned surface vehicle or autonomous surface vehicle were in the Bay. I joined our research vessel, Bay Hydro, out of Annapolis, or Solomon's Island, pardon me. And I got on there. We have an autonomous surface vessel that the University of New Hampshire has helped us work on developing. That I did some seafloor mapping and charting of wrecks just off my Western Shore front porch, just as a demonstration. I live in North Beach, Maryland. The second thing is our ship Thomas Jefferson, which is a hydro ship. She was demonstrating a very novel ASV called the Drix, built by IX Blue, which can go 14 knots with a wave-piercing hull and collect IHO Order 1 bathymetry. Awesome technology there. So we've demonstrated some things in the Bay. I'm working with our Chesapeake Bay office in Annapolis to do more. So great question. Thank you.
Here's another excellent question from Katrina, which is, I am entering a PhD program in fisheries ecology. What resources would you recommend to stay in touch with NOAA's priorities so that I am ready to enter the NOAA job market in 5 years? I think you have a future employee here.
Katrina, great question. Thank you. And I love this because I'm always trying to recruit people. I recruit everywhere I go. I told you I had 3 daughters. They're my biggest recruits. And so you have some competition, by the way. But no worries, that we have room, and I would love for you to join us. And in fisheries, for example, there's just no limit to the interesting and important things you would do. I would say, depending upon where you live, we have regional fisheries science centers and regional offices which do great work and have internship programs. So I strongly recommend you find where those are. We have them we have the science centers and regional offices in the Northeast at Gloucester and Woods Hole, in the Southeast at St. Petersburg and Miami, in the West in La Jolla and Seattle, and in Hawaii too, in Honolulu. And I might be leaving a few out, but wherever you are, you will be able to, they have subordinate offices and labs too. So you probably have one close to you. Look that up and contact them and find out what their internship opportunities are. And that will be your opening door.
Thank you. I need to especially give a shout out to Elizabeth Sidden, who is thanking you for this great talk. And she is the whole reason why you are here, because she, helped us connect when she won that award and met you in Washington, D.C. about a year ago for her great work with NOAA. So thank you, Yvette. Mike Ziegler, who you might know from Alaska and NOAA, he asked, can you describe for students in the seminar technologies such as sail drone used to track the prey of fur seals in the Bering Sea? And this year there was an autonomous survey with hydroacoustics. Doing pollock distribution. He thinks it's really cool and he wants you to sort of call that out.
Jennifer, was that Matt or Mike Ziegler?
Mike.
Okay, Mike, thanks for that. Yeah, well, I'm glad you highlighted that. This is very important, and we're coming to a close soon. So in this COVID era, our ships were pierside, and they were just starting to get underway. And they do very important fisheries surveys, which inform our fisheries management efforts, like setting catch limits to sustainably manage our fisheries. And not having those ships out to catch data on fish was a problem. So it was a management problem, and we don't want to overfish these fisheries. We also want to ensure fishermen can fish, important economically. And what we decided to do, and actually I directed this effort personally. I knew we had unmanned systems capabilities. I said, we need to get them out because this is a solution. If people can't go on our ships, let's use peopleless ships. And that's what we did with sail drones. And it was a brilliant effort. And, we had many people involved that had already tested these technologies of putting sonars on these unmanned surface vehicles. And we had it all ready. We got it in place. We surged, these great people under me, and moved forward to send these drones out from Alameda. And they got into the Bering Sea, and they did a critical survey for one of our nation's most economically important fisheries, the pollock. And that was wonderful because, first of all, it was an urgent need. Secondly, it was a demonstration of proof of concept. Going forward, at least in the near term, we are not going to be it's going to be really hard to do ocean science at sea. We're going to have quarantines and strict protocols and really minimize the manning on ships. Wow. Well, we have this autonomous technology that we're showing can do it. We also have something I haven't talked about yet, and that's telepresence. We use telepresence during our ocean exploration to communicate to shore, live streaming with pretty high-end satellites on our ship Oceanus, satellite transmitters on our ship Oceanus Explorer, to basically create a national ocean lab virtually. And that, we're going to see more of that, and it's valuable. You have us with an ROV sending imagery and video, and scientists ashore, like at the National Systematics Lab in the Smithsonian, saying, "Oh, that's a new species. We need to address that and discover it and study it." So telepresence, AI, autonomy, these are all solutions to help us move forward and not just continue ocean science in the COVID area, but actually advance it. Thanks, Mike.
Thank you so much for answering those questions. It's coming up on 8:30, so we will leave it there. We appreciate that very much. Everybody, please know that our next Rock Talk is next Tuesday, the 25th, same time, 7:30. And Dr. Liz Harvey, who is a biological oceanographer and a relatively new faculty member at UNH, is going to be joining us, and we're really excited for that. All of the information about these talks and events we're doing this summer are on our website, shoalsmarinelaboratory.org, and we record the vast majority of these talks so you can share them with others and students. We definitely encourage that. So thank you so much for your talk tonight, Tim. It was really informative. A lot of us got a lot out of that. Appreciate your time. And thank you all for joining us. Have a great night. We'll see you again next week, we hope. Thank you.